We're doing MCQs from physics O level. The first MCQ is about springs and extension. A spring extends by 4 centimeter when 10 Newton is suspended from it. One spring would extend by 4 centimeter when 10 Newton would be attached to it. But over here we have two springs in parallel. So the load will be divided between each spring equally. So 15 Newton will be the force exerted on this spring and 15 will be on the other spring. Ten Newton extended the spring by 4 centimeters. So 15 Newton will extend each spring by x centimeters. X is equals to 4 into 15 upon 10 by cross multiplication. So the first answer is B, 6 centimeters. Question 2 is about lenses. An object is placed in front of a diverging lens as shown on the scale diagram. The principal focus F is marked on each side of the lens. At which position will the image be formed? In lenses, we'll make two rays to find the position of the image. The first ray will go parallel from the object till the principal axis of the lens. And from there, it will diverge such that it seems that it is coming from the point F. So it will go like this. Now the second ray will be such that it passes through the optical center of the lens. So from the top of the object through the optical center of the lens, these are the two rays. This line will be dotted. And since these two meet at this point that is above C, so the answer will be C. This will be the image. And this image is virtual and diminished. The next question is about dispersion and prism. Light rays are deviated by a prism. The deviation angle D is measured for light rays of different frequency, including blue light and red light. Which graph is correct? So normally in a prism, this is white light coming. The top light is always red and the bottom one is violet. So this means that the angle of deviation of red is minimum and of violet is maximum. So the angle that is D should be minimum for red in the four options. Red has a minimum angle in option A and option D. So B and C are wrong. Now for frequency, it is a fact that out of the 7 lights, red has the greatest wavelength and violet has the greatest frequency. So red's frequency is also minimum. That is shown in option D. So D is the correct option. The next question is from latent heat. The energy required to change liquid water into water vapor at the same temperature is called latent heat of vaporization. What does this energy do? Now, latent heat of vaporization does not increase the temperature or the speed, because speed depends on kinetic energy and speed depend on temperature. So it does not affect the speed or the temperature. Water molecules are not split into their atoms. In fact, the molecules are separated from each other. That is, the spaces between them increase as they turn from liquid to gas. So therefore, A is the correct option. 17 is related to temperature. A 2 kilowatt kettle containing boiling water is placed on a balance. It is left there and continues to boil for 5 minutes. The balance reading changes by 0.2 kg. And we have to find the specific latent heat of vaporization. So the power over here is 2000 watt. 2 kilowatt is 2000 watt. And the time taken is 5 minutes. So in seconds, it will be 5 into 60. So the energy supplied equals to 2000 into 5 into 60. That is 600,000. Now, what we have to find is the latent heat of vaporization. The formula for latent heat is Q equals to ml. Q is energy or heat. So energy equals to 600,000 equals to mass into latent heat. Mass is 0.2 into L. Now we'll divide the energy by 0.2. So latent heat equals to so D is the correct option. The next question is related to magnetization. The diagram shows a brass rod and an iron rod beside each other at the bottom of a rectangular coil. What happens when a DC current passes through the coil? Now, a DC current would make the iron rod a magnet because iron is a magnetic material, but brass is an alloy of copper, and copper is a non-magnetic material. Therefore, only the iron rod is magnetized. So B is the correct option. Question 39. In the treatment of brain cancer, a patient's head is enclosed in a helmet containing a number of radioactive sources. The radiation from each source is directed towards the cancer. Which nuclide is the most suitable for these sources? For killing cancerous cells, gamma rays are used, and a long half-life is suitable because if the half-life was short, then the activity of the source would decrease very rapidly and could not be used anymore. Question 30, the next question, the electric circuit shown is used to study the charging of capacitor C. The neon lamp lights when the PD across the capacitor C reaches 110 volts. C then discharges through the neon lamp. When C has discharged, the lamp goes out and the PD across C slowly increases once more. What is the effect of increasing the resistance of R? Now, when the resistance of R is increased, the voltage across R will also increase. Therefore, the voltage across the capacitor decreases. Now, when the voltage across the capacitor decreases, it takes the capacitor more time to charge up. That is why the lamp will light up less frequently and goes out less frequently. Next question, a simple model of a DC motor is made. By mistake, the split ring commutator is left out. The coil can turn, but is always connected to the battery in the same way. The coil starts in the horizontal position. What happens to the coil when the circuit is switched on? Now, when the circuit will be switched on, the coil will start rotating according to Fleming's left-hand rule. However, when it reaches the vertical position, there is no turning effect because of the graph for the DC motor is somewhat like this. The y-axis is for the turning effect, and this is time. Now, when at this point, the coil is vertical, so there is no turning effect because all of the field lines pass through the middle of the coil. In a normal DC motor, which has a split ring commutator, the inertia makes the split ring commutator turn, and as the contacts change, the current's direction is reversed. This makes the coil to keep rotating in the same direction. However, if the commutator is not there, as in this case, so once the coil reaches the vertical position, it won't be able to keep rotating and will stop there. So C is the correct option. Next question is about half-life. A radioactive isotope has a half-life of 6,000 years. How much time passes before the rate of emission from a sample of this isotope falls to 1/16 of its original value? 1/16 is equals to 1/2 whole power 4. This means that 4 half-lives have passed. Since 4 half-lives have passed, so the time that has passed will be 4 into 6,000. That is option C, 24,000 years. Now again, if we use the formula over here, the formula is so if this is the original value and this part has to be equals to 1/16. So that's why n will be equals to 4. So 4 into 6,000 will be 24,000. The next question is about energy change, energy transfer. A parachutist has opened his parachute and is falling to earth at constant speed. What is the principal energy conversion taking place as he falls? The phrase here, constant speed, shows that kinetic energy is not changing. Therefore, potential energy is converting to thermal energy or heat. If the speed was increasing, then the option would be C, as potential energy would be converted to kinetic energy. But as it's constant speed, so D is the correct option. The next question is about resistance. The resistance of a cylindrical wire P is 80 ohms. A second wire Q is made from the same material the cross-sectional area of Q is 4 times that of P. The length of Q is twice the length of P. So the formula for resistance is R equals to rho L over A. Rho is resistivity and it depends on the material. So as the material is same, so rho will remain the same. Length of Q is twice that of P as given over here. And the area is 4 times that of P. So simplifying this becomes 2. So the total resistance of Q is half that of P. Therefore, 80 divided by 2 equals to 40 ohms. So B is the correct option. Next question. The current in a filament lamp is 0.25 ampere when working normally. The lamp is connected to a plug and the mains AC supply. When the lamp is switched on, it does not light. What is the possible cause for this? The first option says the earth wire in the plug is not connected. The earth wire is connected only precautionally and it does not affect the working of a lamp or a circuit. Option B, the fuse in the plug is 3 ampere. The current required by the lamp was 0.25 ampere. So a fuse with a rating of 3 ampere would be sufficient and this could not be a cause for the lamp not lighting up. The lamp only works on DC power supply. Even if a lamp is working on a DC power supply, it could work on AC power supply, but then on AC, it would keep blinking. But over here, it does not light. So C is also wrong. The only possible option is D, that is the live wire in the plug is not connected. The next question, a steel ball is released just below the surface of thick oil in a cylinder. During the first few centimeters of travel, what is the acceleration of the ball? Now, if a ball is released in oil, there is a very strong opposing force in the oil. So the acceleration of the ball will keep decreasing because the resultant force is decreasing constantly as the opposing force is increasing. Therefore, option C is the correct answer. An aeroplane is halfway along a runway before it takes off. The arrows show the directions of 4 forces acting on the aeroplane. The drag forces on the aeroplane are negligible. The gravitational field strength is 10 Newton per kg. The acceleration of the aeroplane is 2 meters per second square. What is the largest force? The first option is the force on the wheels from the ground. The second is the lift acting on the wings. The third is the thrust from jet engines, and the fourth is the weight of the aeroplane. If the force on the wheels from the ground was the largest force, then the aeroplane would have been pushed up by the ground and it would not have been running on the ground. It would have been afloat. Option B, the lift acting on the wings. Again, if the lift acting on the wings was the greatest force, then the aeroplane would be flying and would not be on the ground. The third option is the thrust from the jet engines. The thrust from the jet engines is producing an acceleration of 2 meters per second. Therefore, the force would be acceleration into mass. Mass, let's take mass as m. So the force over here of the jet engines would be F equals to 2m. The fourth option is the weight of the aeroplane. Now the weight of the aeroplane has acceleration 10 Newton per kg. So the force of the weight or the weight will be 10 times the mass. So 10 m. Therefore, the greatest force is the weight, and D is the correct answer. The next question, an ice cube at a temperature of 0 degrees Celsius has a mass of 10 gram. The specific latent heat of fusion of water is given. How much heat energy is needed to convert the ice cube into 10 gram of water at 0 degrees Celsius? The formula for this is Q equals to ml. Latent heat of vaporization of latent heat of fusion is given as 3 into 10 to the power 5 joules per kg, and the mass is given as 10 grams. We will need to have the same units, so we will convert 10 grams to kg. That is 10 divided by 1000. So 0.01 kg. So we'll multiply that with the latent heat. The answer is coming 3000 joules. So B is the correct option. Next question, a body slides down a frictionless slope as shown. As the body presses on the surface pushes back on the body. The force of the surface on the body is sometimes called the reaction force. In what direction does the reaction force act? Over here, what they're talking about is Newton's third law. That is, to every action, there's an equal and opposite reaction. The body is applying a reaction, is applying an action or a force on the ground in this direction. So the reaction will be in the opposite direction, that is C. So C is the correct answer over here. Paper is sold in packets labeled 80 gram per meter square. This means that a sheet of paper of area 10,000 centimeters square has a mass of 80 gram. The thickness of each sheet is given, and we have to find the density of the paper. For density, we need mass and volume. The mass is 80 grams. Now we need the volume. As a sheet is in the shape of a cuboid, so the formula for volume will be length into base into height. They have given us the answer of length into base, length into width, that is 10,000 centimeters square, and the height is 0.11 millimeter. We'll convert 0.11 to centimeters. That will be 0.11 divided by 10. So 0.011, and for the volume, multiply it with 10,000. This is coming equals to 110. This is the volume in centimeter cube. So we'll divide 80 by 110. The answer is coming 0.727, approximately 0.73. That is option C. The next question, when there is no wind, the engines of an airship push it due north at 20 meters per second. The wind is blowing from the west at 12 meters per second. Which vector diagram correctly shows how the resultant velocity r of the airship is obtained? Now 20 meters per second has to be in the north direction. So the vector of 20 meters per second is drawn correctly in all of the options. However, for the second vector, the wind is blowing from the west, means that the wind is blowing towards the east from the west. So option B and D are wrong because the 12 meter per second vector in B and D is drawn from east towards the west. So from A and C, the correct way of taking out the resultant vector is shown in A. That is, we find the diagonal of the rectangle. So A is the correct option. The diagram shows a circuit containing 5 resistors connected to a battery. In which resistor is the current the smallest? Current is inversely proportional to the resistance. Over here, the current will be maximum. For example, we can take it as 4 amperes. Now, the current in these two resistors will add up to 4 amperes. And also the current in these two resistors will add up to 4 amperes. Over here, the current will be divided equally. So it will be 2 amperes in the upper resistor and 2 amperes in the lower resistor. However, in the middle parallel combination, the current will be divided in the ratio 3:1. More current, 3 amperes, will go through the resistor marked B because it has lower resistance and current are inversely proportional. So the resistor with 10 ohms will have 3 amperes and the resistor with 30 ohms will have 1 ampere. Now the smallest, and in D, the current was 2 amperes because it is divided equally. Over here it's 4, so the smallest current is in option C.